My name is Uri, and in the last few months, I've been part of a team, like a joint team between Facebook and Apollo and other people from the community, where we basically build together the spec for GraphQL subscriptions. It's the new version of the GraphQL spec. And today I'm going to talk a bit about it and how you can use it today, and also how you can use more stuff that are maybe not in the spec right now and use it already in your apps today. So a few months ago, we started working on the GraphQL spec for GraphQL subscriptions. It was the first time that GraphQL subscriptions added a spec with a collaboration from outside Facebook. And it was a really, really interesting process. We sat a lot and thought about what to add and what are GraphQL subscriptions, but also what is not GraphQL subscriptions. And at the end, we ended up here, which is Rob Zhu from Facebook did a PR including GraphQL subscriptions into the official GraphQL spec, and I PR'd the GraphQL official reference implementation to add subscriptions into that. And then on May, on GraphQL Europe, we announced that it's officially in the spec and you can use it, even though you could use it before. GraphQL subscriptions talks about how to basically also push data, real-time data, from the server to the client. But there's many ways of doing that, and I'll explain a bit the whole process. But first, for those of you who still don't know what GraphQL is, I'll do a very quick intro. So GraphQL is a query language. That's it, just a query language. You can query data. Which data? Any data. So we'll see it right now. I can basically just describe my data in a very simple way. Then I can ask for what I want, and I get exactly that. I know what I'll get, no more, no less. So how does it actually work? So first of all, I describe my data. So I'm writing it in a very simple language that you can see here, like just types and their annotations. But then what you see in the middle here, this is the GraphQL engine. Luckily, you don't need to write this thing. So this thing, just from you writing your types, can automatically bring the data from whatever the data is and send it back to the client like the client wants it to be. So if I'm writing now a client query, which looks pretty similar, pretty easy, and then the client sends a request for the GraphQL engine. Now the GraphQL engine starts to fulfill that data no matter where it is, and then combine that data together into one single response that looks exactly like what you queried. So that means that you don't need to wait anymore for syncing multiple requests into your client. And the other thing that you don't need to do is actually now, after you got all the data into the client, start to structure the data in a way that you can render it. You get the data exactly like it looks like. So for example, let's add another request, which maybe we'll call another data source. And now the GraphQL does basically the same, but you can see that it will also query. Now it's query the user, then the username and messages from the server. But then let's say the content of those messages will come from a third-party API. Let's say WordPress API or something, or Contentful. And the amazing thing here is that, again, it will call a third-party API. The client doesn't know. Client doesn't know and doesn't care. And then you will get back the response in exactly the way that you expect. So it simplifies tons of code, both on the server and the client. But more than that, it also gives you type safety over the network. So when I'm writing now code on the client, I know exactly what data can I get. And I know if I'm making a mistake in development time, I know that I'm making a mistake. I don't need to go to production, call to a REST API, and then one day I'll get one data, a specific data, and the next day I'll get something else because the server developer decided to change something. So this is very powerful, but also I get from those, just from typing those a few, describing the data with this simple schema language, I get automatic docs. All the docs that you need out of the box. Like everything you see here, you don't need to develop. It's already developed. But what if I can tell you that any data also mean your local data? What if I can run those queries from my components of my app? So I can do basically the same process that I've done before, but against doing a remote server, I'm doing it against my Redux store, for example. And that gives me a huge benefit because I can delete a lot of code on the client that we do today with like actions and reducers and all kinds of like code that we write ourselves. This thing can do it automatically for us, while it's only in the client, so I can actually do that just on the client and then keep using REST and HTTP. I don't even need my backend developers to know what GraphQL is. So that's actually something very, very interesting. So, and a huge revolution, I think, in the concept of GraphQL. And if you really want to see how it's done in a good way and not how I showed you now, you should really check out tomorrow's talk, Peggy's tomorrow's talk. It's going to blow your mind. Like, seriously, you have to watch that talk. And the last thing that I'm going to talk about in the intro to GraphQL is actually that we can actually today, from that schema, do even more. We can generate code. So we have these static typings. We can generate TypeScript typings, C# classes, Java classes, and even actual code, ORM code, and full backends. So like in 2 hours from now, I'm giving a lightning talk just about that subject where I'll just create a full backend from just like running a one script. And it's open source. It's not like a backend as a service or something. So I hope you can come to that as well. But there's one more thing, which is actually the reason that I'm here and the reason they invited me here, which is real-time. So GraphQL actually gives us, because it works on any protocol or on any data, then we don't need to think in terms of REST anymore. And REST is very limited REST is connected directly to HTTP. And HTTP is a bit limited. With GraphQL, we can use any transport. So we can expand the things that we can do. Real-time is one of them. And when we talk about real-time, I think we should distinguish about what is actually real-time. And there's many types of real-times that are, or real-time implementations that are fitted to each different use case. So it can be a chat. It can be just a presence, like is the user online or offline. We can just see like graphs for stock markets and many more other like use cases. Now, the reason I'm putting the use cases here is that soon I'm going to talk about basically 3 types of real-time protocols or ways to do real-time: polling, subscriptions, and live queries. And I'm going to explain them because for us in the spec, we needed to realize what GraphQL Subscription is and what is not, and for which use cases GraphQL Subscription fits, and which use cases you would rather do polling or live queries. So I'm going to cover that a bit as well. So too often when you hear about real-time, you think about like this like magical service in the cloud that basically just propagates data into your application. So it's like you're running a local query on your devices, on your clients. You write all your code on your client. You just update like this simple store on your client, and then everything magically being synced everywhere. And that's true. Like you can do that, and there's amazing services that do that. But that's actually very hard. And why is it hard? Because in order for me to actually listen to data and to know when data is happening, or when data is changed, I have to realize all the dependencies of the data. And this is something not super simple. And you need to have specific infrastructures to do that. For example, today you can use RethinkDB, which is an interesting database that gives you that ability. You can use Firebase and Firestore, which maybe I'll touch a bit on them and the differences between them. And also you can use Mongo with Meteor. Meteor basically listens to the Mongo oplog and then gives you those abilities as well. But there's a problem with all those solutions. What if I don't have a reactive backend? What if I currently have an existing app? Maybe I work in a bank, on an IBM infrastructure. Maybe I have PostgreSQL, maybe I have, I don't know, an existing Mongo database without Meteor, and I can't now just put Meteor on all my stuff. And another thing, what if I can't pay a service to do that? I want my data to live internally, and I don't know what is happening with my data on the cloud. So I think one solution that people too often are looking at something that is not good is polling. But it's actually a great solution because you can use, what is polling? Polling is basically, OK, I have a query. I'll just run it again and again and again, like every second or every 20 seconds. And that actually solves a lot of problems. It means that I know that the data will keep being consistent on my clients. And I know that, and I don't need to change anything. Like if I have like an old HTTP server, it will work. I don't need to change nothing. But there are some issues with polling. Like one of them, for example, if I'm sending a query and get back the result and then was the change, I will miss the change. And then only the next time I will query, it will happen. Another problem is I might send a lot of requests that are just too expensive, that nothing happened. Why would I send those requests and overload my server? So what can we do with real-time, even if we don't have reactive backends? What can we say on our backends that can tell us this happened right now? So let's think about like a regular server. And I have a client, and the client basically performs a regular HTTP request. Now, on the server, if you can see the code on the bottom, is basically there's a regular server method, add message. And I just save the new message in the database, get a response that it happened, and then return that response. But I actually know right now that a new message has happened, so I can actually trigger a change. And if I had some kind of mechanism to trigger a change or trigger an event and send it to the client, then we'll get real time, even though we don't have a reactive backend. And this can run on any code. I wrote here a JavaScript code, but it can be, you know, like a, I don't know, Perl code or C++ code or whatever. So PubSub or publish subscribe, it's a known method to do those things. And there's many solutions that give you that ability. You basically, one side is subscribed to an event, and the other side is listening to it. So now I can, from the server, just call a method on the PubSub, and the PubSub will take care of sending that to my client, and I get real time on top of my existing data. Now, if you think about solutions that give you that PubSub mechanisms, like services, you can think about PubNub or Pusher and those kinds of things. But also, there's a lot of open source solutions out there that will give you those abilities. So in the next slides, I'm going to, later on in the talk, I'm going to like dive deep a bit into how you actually go in and do those things yourself and all the things that you need to take care of. But let's say now we have publish subscribe method, and we get real time, and that's great. But there's a few problems with that. One, as the client, how do I know which events can I subscribe to? It can change any day, right? We're all developers. Everything breaks and changes every day. Another thing is, you know, when the server publishes data, when it publishes an event, it can also send data. But I don't know what data the server can send me, and I don't know if I can get it or not. So that means that I have a problem. With every event that's happening, maybe the server will decide to send too much information, overloading my network. The other thing, or maybe I'll take another thing and I will say, okay, a message was added, here is the ID of the message. Now, what the client can do is, again, go and send an HTTP request with the new message, which is a valuable solution. But what if we could actually decide what data on the client we want to get and query it? Also, like, if something changed on the server, I want to know that I'm not breaking anything, and all the code that I'm writing on the client is still OK a long time. So that sounds very familiar. Like those problems that we actually talk about is actually what GraphQL has solved for HTTP. So what if we can bring GraphQL into that space as well? And this is exactly what GraphQL Subscription is. So GraphQL Subscription basically let the server describe in the same schema that you saw before what events are being exposed, and also what data can be sent over the network with those events. And then the client, just like a GraphQL query, can decide which events he wants to subscribe to and which data exactly he wants to get they want to get back. And the most important thing, like GraphQL, it can work on top of any event source and any data source. So let's see how it actually works. So first thing, we write a schema. So you can see on the bottom left, we have we just added to our schema, we added a subscription. The subscription says message added. And then on the client, what we want to say is, I want to subscribe to message added, and every time a message was added, I want to get the author and the content. So this is already very powerful. On the client, I can say which events I can subscribe to and get the data and do whatever I want with it. So let's see what happens actually. So the client sends a query, but this time, if you see the line between the client and the GraphQL, this is actually a two-way connection, which we'll talk a bit in a second, but it's like WebSockets or something like that. I need to send a request, and I need to get a response and keep getting responses later from that. And what happens now is that I basically created a subscription, and now the server can send that message that we saw before into GraphQL. Now, once the server will send that message into GraphQL, GraphQL will do a very amazing thing in order to send me the data that I want. It can go ahead and parse that query for the specific client and get me all the data that I want from any source. So that means that, let's say, I fired an event on the client, on the server, I can still get real-time data, not only from my server, but from a third-party API. And I'll get the response that I'll get is exactly like a query, exactly what I want, and I actually enriched the data. I had the power to get just the limited amount of data that I want, but also if I want data from GitHub API, I can get that even though the source of the event was my own server. But the source of an event can actually even be like an IoT device. I can trigger an IoT device, or it can be a webhook, or it can be an SQL trigger, or whatever I want, trigger that response, and again, run through all that to the regular GraphQL engine and get exactly the data that I want. So this is very powerful. I can put this, I can put this box or technology, open source technology, into my existing stack no matter what it is. It can be like the oldest thing in the book. Like one thing that I did was go into a bank and actually add that on top of like this really, really, really old queue from IBM. And it worked. It made us have accomplished real-time updates on the React Native app for the bank. So this is like all fair and square, and this is great, but actually there's some problems when we get into real-time, bidirectional data, and things like that. Now, one thing that I want, let's talk about three common problems. One is I need to send bidirectional data over the network. I'll talk a little bit about that. Another thing is what happens if the connection fails. What do I do with the data and the events that happened when I was offline, in the train, or I don't know when? And the third thing is scaling. Like, there's a problem now because all the clients are staying connected to my server. And this is maybe harder to scale. Now, one thing that I want to say here is that too often, the information about those things, when you go online and Google those things, is a bit misleading. And the reason is that the companies, the service companies that provides those PubSub mechanisms out of the box in the cloud, their interest sometimes, and it's not that they're bad, it's just how marketing works, is to tell you that their solution is super, super simple, and if you do it yourself, it's super, super hard. But that's not completely true. You need to take care of a lot of things. I'll cover some of them. It's not like giving a talk about scaling can be like an hour long, but all those problems can be done with open source tools that are very advanced and are used by companies like Twitter and Google and Facebook. So let's talk about one first problem, bidirectional transport. So what you see here is that we created basically a link between our clients and our GraphQL servers. But this link is constant, it's there, and also one thing that we forgot, and it's important to mention, it's the internet on the other side. So one thing that HTTP simply is harder for the HTTP to actually accomplish those bidirectional transports, we call them. I won't go too deep into that, but what I can tell you is that there are solutions for that that are very widespread, and those are known problems and solved problems. So one of the most often things that people use are WebSockets. WebSockets now are supported in any web browser, and there's an amazing amount of code and libraries that do WebSockets in very high performance and scale. And one of the things that they do is also, let's say somehow your browser can't come up with WebSockets. Maybe because it's a very old browser, or maybe because you're behind firewall. Those libraries will fall back into other solutions for you. You don't need to take care of that. Another thing is actually to use like all the existing solutions, like server-side events and HTTP long polling, which are part of HTTP. Another thing that you can do is actually use MQTT or all kinds of queue messaging things in order to make sure that everything you send over the network will get there. But basically, what I'm trying to say is that there's many, many solutions for that. It's a known problem, and you can basically use anything out there. The GraphQL spec doesn't dictate which technology you use. Everything that I talked right now was, okay. The next problem is offline. What happens if now the internet is gone? I'm behind internet. So here also, what those services are giving us is actually a local store that with some logic that tells us what to do when the network is off, what to do when the network is on, and that's okay. But there's open source solutions for that. If you conform to an open API like GraphQL Subscriptions, then there's tools you can build yourself to do that, or use open source tools that does that for you, like Apollo Client and Relay. So those solutions will actually have a built-in ways, in an open source way, that you can change in order to handle those things. So, and to hear more about those things, you should really, again, check out Peggy's talk tomorrow. Okay, I keep forgetting that there's an animation there. So the last problem is scaling. And that's probably like the main thing that I'll cover right now, and I hope I'll have time. So scaling is a hard problem, but again, and maybe it's a bit harder with live queries and publish subscribe, but it's also a known problem. And there's a few things you can make sure to do in order to make that problem much easier for you. First concept that you should remember is actually separate the stateful things and the stateless thing. What do I mean by that? A GraphQL server is stateless. Every time it's like an HTTP server. Every time it will get a request, it will send a response, and it doesn't hold any state whatsoever. But when we are connected into that GraphQL server with an event stream or with a transport like WebSocket, now the client actually subscribes to an event. So the client is state there. Like I need to know which client are subscribing to my data. So this is actual state. So this is one thing I'll show you now, how to separate the two. Yeah, and the next thing is that sometimes when you scale, you need to make sure that the right data will get to the right places. Because maybe you have multiple instances and some event happens, you need to make sure that first of all, that everyone who wants that event will get that event. And the second thing, that that event won't fire if someone else has already handled that, for example. But again, here, you have existing solutions like Redis and Kafka and all kinds of existing solutions that all companies are using today with great success and not so much trouble. So how can we actually do that? Right now we have a lot of clients that are connected to the same GraphQL server, and this can overload the server. What we can do is actually scale those servers, and then put some kind of a PubSub mechanism. It can be a service, but it can also be an open source tool like Redis or Kafka that will make sure that the right messages will go into the right servers, and then you can scale your servers as much as possible. The GraphQL servers can just be scaled as much as you want. Another thing that those tools will do is actually quality of service, QoS. You have all kinds of levels of QoS, like I'm sending a message. Is it guaranteed that the other side will get the message or not? Maybe I send a message and I don't care if it will guarantee. And there's costs for everything. Now, the open source tools actually gives you the level of control over that. You can just control that. And you understand exactly how much does it cost and how much not. With services, it's not always the same. They decide for you what's the quality of service you want and what's the price you're going to pay. Another thing is the actual subscribing and the publishing of events. Let's say I'm listening to my data source, but I want to scale and send it to multiple clients. Again, the GraphQL servers are stateless, so I can just scale them horizontally, and then the PubSub will make sure that everyone who needs that information will get that information. And if you want to scale your databases, also there's many, many possible solutions out there. I won't cover that today. Okay, so what you can maybe until now understand from my talk is that live queries are really awesome and really good. I always want to do live queries, but if I can't, I will just use subscriptions over my existing data. That's not entirely true, and this is a huge debate that we had also in the spec work. Actually, what we came up with is that subscriptions are valuable because they give more power to the client, and they tell you not just that data has changed, they tell you why. So you can respond to that change. For example, if we're thinking about the use cases before, maybe if I just want to display the price of Bitcoin, I can do it in a live query because I can just put the updated data all the time. But if it's a chat, maybe I want to get a notification when it happens, or maybe I want to do an animation. So with subscriptions, it's actually a better solution for those types of use cases. And with GraphQL subscriptions, it's actually, if you think about it, it's a bit in the middle because you get kind of both worlds in a way, because I get PubSub messages, but I also get the data that I want and the updated data. So it's very, very powerful, and maybe I don't even need live queries at all. But like I said, sometimes you do. And people think that live queries are a bit for simplistic use cases, like I'm building a POC, I will put a live query in, and it will just work. And that's true, but it's also for very hard cases. For example, what if all those data dependencies that I have are so many events that I can't cover those? I can't, let's say I want to update the likes on a post. There's many things that could happen. Maybe someone unliked a post. Maybe someone deleted their account from Facebook. Maybe someone became my friend, so I need to also put by the number also my friends. It's very hard to cover, so in that case, actually live queries simplifies the code for us. So what if you could, but it's not in the spec, right? GraphQL subscriptions is in the spec, live queries are not. Well, that's not quite true. So it's not in the spec, but there's a lot of work that we have been doing in order to support that. One very nice library is a library called GraphQL Rxjs, which basically instead, on each point that we get data, instead of getting data through one time, for example, like through a promise, I can actually get an observable. And that data point will keep firing back. I'll show you how it's done. So what you see here is that on the query, I put just on the content, on the specific data that I want to be live, I'm putting a live annotation. And then what I can do is I will do the queries again, and like regular query, everything will be solved, and I'll get back the query that I want. Now that's okay, but I keep two things are happening here. One, the client is still connected to the GraphQL server. The other thing is that the dot on the bottom is still connected to my reactive database. So now, if something will change in my reactive database, the following thing would happen. I will get that data, just that data, propagating it again and fire into my client. And the data that I'm going to get is just the delta, then what changed and where is it changing. So my tools on the client can just pop it into my data store, and everything will be updated magically. So I don't have a lot of time, but so you can use GraphQL live queries today. How can you do that? Well, you can use all the existing stuff that I showed you, like Firestore. But in that context, you put Firestore where I think it belongs. It belongs as your reactive database, not as a solution for your whole thing, and you can easily migrate from. You can use RethinkDB, you can use Meteor, but then there's a new thing, which I want to, this is the first time I'm talking about it, but there's Mongo 3.6, I don't know if you heard, is going to come out with a new change stream ability, kind of like what RethinkDB is doing. It's very new, and it's in RC0. It was published 2 weeks ago, and actually this weekend I wrote for that talk a library called Mongo Rxjs, which now you can use that, and it's under my GitHub, and yeah, like 1 minute I'm finishing, I promise. And you can use it today, and then it means that if you use Mongo today, you can also get live queries. You don't need to move into different things. Okay, I'm finishing up. So again, are services bad? No, they're great, but if you would use today you can use in all the ended of the solutions, you can use standard protocols. And that means that you can migrate from a solution. You can put the solution where they belong to. So some libraries that you can use are here, and also I wrote a lot of examples for many, many different implementations and technologies under my GitHub repo. I won't cover it because I'm being thrown out of the stage.
No,
but
very nicely asked.
I'll just ask one last thing. Let's all together request from the service providers to move to a standard protocol over their solutions so we can have more power in using them the way that we want. And if they won't do it, you can just go to my GitHub and do it yourself. Thank you.
Great. Thank you very much. Uri, thank you very much for the talk. Unfortunately, we've eaten through the time for Q&A, but where can the guys find you during the coffee break if they want to talk to you one-on-one? What about right there?
Yeah, I'll be
right there. Great. So after this talk, you'll be there for asking questions, the old school way, offline. Uri, thank you so much. Appreciate it. Thank you.